Good morning, students. In the last class, we discussed about the topic that is radioactivity. So, Henry Becquerel first discovered the phenomena of the radioactivity. So, radioactivity is a nuclear phenomena in which the number of the nuclei disintegrate with respect to time, right? So, for that, we have radioactive decay law, or we call that one as the decay law, right? The statement of the decay law is the rate of nuclei disintegrate with respect to time, so that is proportional to the number of the nuclei which is present in that atom or the present in that sample, right? So from this we derive N is equals to a naught e to the power of minus lambda t, right? So where N is the number of nuclei at arbitrary time t. So N is the number of the nuclei which is present in that sample at the arbitrary time t, and N naught is the number of nuclei at t is equals to 0. So we call this one also parent atom or parent nuclei, right? So N naught, and we have lambda, that is decay constant, right? So where N naught is also the constant because it is consists of the sample. If you consider this one as the sample, so this sample consists of constant nuclei. That one is the N naught, right? So where N is the number of the nuclei which are disintegrate at the time t. That means t is here. Here N naught is the constant and N varies with the time. Here lambda is also the constant with exponentially, right? So if you plot the graph for this, we have N and here we have time, right? So if you plot the graph means we get linearly decreasing exponential curve. So this one is the plot for the radioactive decay law, where N is equals to N naught e to the power of minus lambda t, right? So where N is the number of the nuclei at the arbitrary time t, and N naught is the number of the nuclei at that time t is equals to 0, and here at time t is equals to 0, that one we call as parent sample or parent atom, and lambda is the decay constant, right? So from this we have one definition, that is activity. So what is activity? So activity is nothing but it is defined as the ratio of number of decays per unit time. That means the number of decays per unit time, or simply we call this one as decay rate. So that one is defining the activity. So activity is defining by R, right? So that is equals to dN by dt, right? So what is activity? Activity is the number of decays per unit time, right? So here N is the number of the nuclei. So dN by dt is the rate of decays. That one we call as activity. R is equals to dN by dt. So the definition of the activity is the number of decays per unit time, or simply we call that one as the decay rate, right? So decay rate is also called as the activity, right? So activity is defined as the number of decays per unit time, and it is defined by the letter R. So R is equals to dN by dt, right? So as we know N here, that is N is equals to N naught e to the power of minus lambda t. Now if we substitute here, R is equals to d by dt of n naught e to the power of minus lambda t. Now here, as already says, n naught is constant, so we need to differentiate d by dt with respect to time. That is the term e to the power of minus lambda t, right? So if we take n naught outside, n naught into, so differentiation of e to the power of minus ax is equals to minus a e to the power of minus ax. So here we have e to the power of minus lambda t. Here minus lambda is constant, right? So if you take minus lambda, right? So e to the power of minus lambda t, right? So as it is disintegrations per unit time, so here we have r is equals to minus dn by dt, right? So here also minus and here also minus, right? So the activity r is equals to, so minus into minus plus, that is lambda n naught e to the power of minus lambda t, right? So lambda n naught can be written as constant because lambda is constant and n naught is also constant. So replacing these two constant by a single constant, so that one we taken as r naught, right? So r is equals to r naught e to the power of minus lambda t, right? So this one is the activity. R is equals to r naught e to the power of minus lambda t. So n is equals to n naught e to the power of minus lambda t. So this is different from r is equals to r naught e to the power of minus lambda t. So this is only the nuclei. So this one is the nuclei which disintegrate at the time t. So here n naught is the parent nuclei. That means at the initial time we have n naught number of the nuclei present in the sample. After certain time t, we get the nuclei in the form n is equals to n naught e to the power of minus lambda t, right? So here r is the rate of decay. That means r is equals to minus dn by dt, right? So r is equals to r naught e to the power of minus lambda t. Here r naught we taken as lambda n naught, right? So that means at time t is equals to 0, we have activity r naught is equals to lambda n naught. Means initially we have a sample n naught and we have the activity r naught is equals to lambda n naught, where lambda is the decay constant, right? So at r is equals to lambda n at some arbitrary time t, right? So these are the two important conclusions, right? So here r naught is equals to lambda n naught at time t is equals to 0. That means initially we have the sample of the nuclei n naught, then its activity is r naught, right? So next we have the decay constant lambda after some time t. So the nuclei reduces to n, that is it reduces from n naught to n. That means it decays from n naught to n. So that one we call as the activity r. That is r is equals to lambda n at the arbitrary time t, right? So this is about the activity, and the SI unit of activity is becquerel. So this one is important for 1 marks. They asked in the previous year, right? So what is the SI unit of the radio activity, or simply they ask the activity? So the SI unit of the activity is becquerel, right? So this can be written as BQ. After the Henry Becquerel, who first invented the radioactivity, so for that they given the unit of the activity is becquerel, right? So one more unit of the activity is Curie, right? So the SI unit is becquerel. So one more unit of the activity is Curie. So 1 Curie, that is 1 Ci, that is equals to 3.7 into 10 to the power of 10 becquerel, right? If in case they given in the problem Curie, we need to convert Curie into the becquerel. So for conversion of 1 curie into becquerel, we have the value 3.7 into 10 to the power of 10. We need to multiply 3.7 into 10 to the power of 10. Then we get curie in the form of becquerel, right? So the SI unit is becquerel. So don't confuse with becquerel and curie. So curie is the another form of the, that is another unit of the activity. So 1 curie is equals to 3.7 into 10 to the power of 10 becquerel, right? So that means the number of decays per unit time, that is decays per second. So that one we call as becquerel, right? So decays per second is called as the becquerel. That is SI unit of the activity is becquerel, and the definition of the activity is the number of decays per unit time. So that is denoted by R. So R is equals to minus dN by dt, right? So as already we know the value of n, that is n is equals to n naught e to the power of minus lambda t. Now substitute here, and if we differentiate here, n naught is constant, so keeping outside, only differentiating this value e to the power of minus lambda t, right? So here lambda is also constant, right? So then e to the power of x we get, if we differentiate e to the power of x, we get e to the power of x. So here we have in the form of ax form. So e to the power of ax is equals to a into e to the power of ax, right? So a value is minus lambda into e to the power of minus lambda t, right? So here this value lambda is constant and n naught is also constant. So we are replacing these two constants by a single constant, that is r naught. So r naught value is lambda n naught at time t is equals to 0. That means at the initial time we have the activity r naught is equals to original number of the nuclei which is present in the sample, right? Where lambda is the decay constant. And finally the SI unit of the activity is becquerel, right? So another unit of the activity is curie. So 1 curie is equals to 3.7 into 10 to the power of 10 becquerel, right? So this is about the activity. So next, define decay constant, that is lambda. So what is, how we define the decay constant, that is lambda, right? So decay constant is defined as, for decay constant lambda, that is equals to the reciprocal of the time. So when the lambda value is equals to 1 by t, then the parent atom nuclei reduces to 1 by e times of the initial value, right? So that one we call as the decay constant, right? So when lambda is equals to 1 by t, then now we substitute this value in this equation, we get n is equals to n naught e to the power of minus lambda t, right? So here we are taken lambda is equals to 1 by t, that is the reciprocal of the time. For lambda is equals to 1 by t, then the n value is equals to n naught e to the power of minus 1 by t into t, right? So here t get cancelled, so we get remaining n naught e to the power of minus 1. So e to the power of minus 1 can be written as n is equals to 1 by e into n naught, right? So here 1 by e is also constant, so e value is 2.303, right? So n is equals to 1 by e into n naught. That means when the lambda value is equals to the reciprocal of the time, then the nuclei in the sample the nuclei in the sample reduces to 1 by e times of its initial value, right? So where n naught is the initial value, that means the parent nuclei reduces to 1 by e times when the lambda value is equals to 1 by t. So that one we call as the decay constant, right? So when the lambda is equals to the reciprocal of the time, then the nuclei reduces, that is nuclei in the sample reduces to 1 by e times of its initial value, where n naught is the initial value, that means parent nuclei, right? So when n naught is the parent nuclei, then when lambda is equals to 1 by 2, the n value is reduces to 1 by e times of its initial value, or 37% of initial value, right? So if we simplify 1 by e, we get n is equals to 0.37 n naught. So if we written in terms of percentage, the initial value is n naught. So the number of nuclei reduces to 37% of its initial value. So either we can define like this or we can define like this. When the lambda value is equals to the reciprocal of time, then the number of nuclei reduces to 37% of its initial value, or we can say 1 by e times of its initial value, right? So this is the decay constant, right? So if we define the decay constant, so it is defined as reciprocal of time during which parent atom or nuclei reduces to 1 by e times or 37% of its initial value. So this one is the definition of the decay constant lambda. So decay constant is defined as the reciprocal of the time during which the parent atom reduces to 1 by e times or 37% of its initial value, right? So for that, lambda is equals to 1 by t. So this one is the mathematical formula and here is the definition, right? So for decay constant, we have n is equals to 1 by e into n naught, right? So this one is the definition of the decay constant, right? So by using the decay law, by using the radioactive decay law, we defining the decay constant such that the value of the lambda is the reciprocal of the time, so during which the number of the nuclei reduces to 1 by e times of its initial value, where n naught is the initial value. You have to remember that one, where n naught is the number of the nuclei at time t is equals to 0 and n is the number of the nuclei at the time arbitrary t, right? So this is about the decay constant, right? So decay constant unit is per second. So SI unit of decay constant lambda is per second, because we have 1 by t, that means 1 by second, that means per second, right? So the SI unit of the decay constant lambda is per second, right? So similarly, we have one more definition, that is half life and mean life. So half-life, it is denoted by T half. In the suffix we are written T half, right? So what is half-life, right? The time during which the number of nuclei reduces to half of its initial value, then that time we call as half-life, right? So that means the number of the nuclei, that means N0 is the parent nuclei, then the nuclei decays exactly half of its parent nuclei, that means N is equals to N0 by 2 when the time T is equals to T half, that means when T is equals to, so this time T is equals to T half, then N is equals to N0 by 2. That means the decay is exactly half of its original value. So if we have 100 nuclei at time t is equals to 0, that is N0 is equals to 100 when time t is equals to 0, then we get N0 value is 50 for a certain time t is equals to t half, right? So this one we call as half-life. That means exactly half of the nuclei is disintegrating. Here we have 100, then the time for which the nuclei reduces to 50, then that time we call as half-life. So here we have 50, right? So then half-life is N0 is equals to 25. So this time we call as half-life. The number of nuclei which is reduces exactly half for a certain time. So that time we call as half-life, right? That is defining as T is equals to T half. When T is equals to T half, then N is equals to N0 by 2. Now if we substitute to this equation, that is radioactive decay log, then N value, here I will write N is equals to N0 e to the power of minus lambda T. Right now if we substitute this value here, N value is equals to N0 by 2, that is equals to N0 e to the power of minus lambda, small t becomes T half, right? So here N0 get cancels, right? So e to the power of minus lambda t by 2 can be written as 1 divided by e to the power of lambda t by 2. That is 1 by 2. T 1 by 2. Here 1 by 2, that is equals to 1 by e to the power of lambda t by 2. So that means we can write e to the power of lambda t half, that is equals to 2, right? So now taking log on both sides, then we get log e to the power of lambda t half, that is equals to log 2. So here log base e, here is also log base e, right? So here we base is same as that of the power here, then it becomes, this value becomes 1, that is equals to lambda, that is equals to 0.693 whole divided by lambda, right? So this one we give half-life of a radioactive sample, right? So for any radioactive sample, we have half-life T half, that is equals to 0.693 divided by lambda, right? So this formula is very, very important while solving the problem. So in the problem they ask find the half-life and mean life, right? So here half-life we have the form T half is equals to 0.693 divided by lambda, right? So here also by using the relation decay law, N is equals to N0 e to the power of minus lambda T, right? So if we define half-life, the number of the nuclei reduces to half of its original value, then that time we call as the half-life. So that one is the time. Half-life is nothing but the total time of the radio sample to reduce the half of its original value. So that one we call as the half-life, right? So this one is the mathematical expression for the half-life, that is T half is equals to 0.693 whole divided by lambda, right? So here the main conditions are these two. When T is equals to T of, then the number of nuclei reduces to exactly half of its original value. So by using this one, substitute in the decay law, then we get T half is equals to 0.693 by lambda, right? The time during which the number of parent atom reduces exactly half of its initial value. So this one is the definition of the half-life. So what is half-life means? The time during which the number of parent atom reduces exactly half of its initial value. So this one is very important. Exactly half. So if the sample has 100 nuclei, then it reduces to 50. So the time taken to reduce us from 100 to 50. So that time we call as half-life. Right? So if we have 50 nuclei, then the time taken to reduce us from 50 nuclei to 25 nuclei, then that time we call as half-life. So for any radioactive sample, the half-life we have standard, that is T of is equals to 0.693 lambda, where lambda is the decay constant. So time, half-life time is depends on the decay constant, so that one is lambda. Right? So this is about the half-life. So the main condition is n is equals to n naught by 2. That is exactly half of its original value. Right? So this is logarithm, right? So base e or sin ends. So this goes to the left side. So lambda t half log e base e. So this value becomes 1. So lambda t half into 1, we get lambda t of. Now we are converting the natural logarithm into ln, that is base 10. For that we are multiplying 2.303 ln 2. So for ln 2 we have value 0.3010. So if you multiply these two values, we get 0.693 divided by lambda. Right? So this is the half-life. And the last definition is mean life. So this is half-life, exactly half. The nuclei reduces to exactly half, so that time we call as half-life. And the next one is mean life or average life of the sample. For all this defining, we need the radioactive decay law. That is, rate of disintegration per unit time is directly proportional to the number of nuclei present initially, or dl by dt, that is proportional to n. So next is mean life or average life. So this is denoted by tau, right? So this is also very important for while solving the problem. They ask combined. So find half-life and find mean life, right? So the mean life is defined as, that is tau, mean life tau, that is defined as it is the ratio of sum of lives of all the atoms which are present in the nuclei to the So what is mean life or average life is, so tau, that is mean life tau, that is equals to sum of lives of all the atoms which are present in the nuclei to the total number of atoms present in that sample. Sorry, not in the nuclei, that is in the sample to the total number of the atoms which are present in that sample, right? So mean life or average life is defined as, that is mean life tau, that is equals to, it is the ratio means sum of lives of all the atoms in the sample, right? So it is the ratio of sum of lives of all the atoms in the sample to the total number of total number of atoms present in the sample, right? So this one we call as mean time, as similar to average. So we are finding the average of two means. So here we have one mass A and here we have mass B. So if we need to find the average of this mass is, that is average mass, that is equals to A plus B divided by 2, right? So in the similar case we have one sample here. So if we consider this one is one sample, so this sample consists of many number of atoms, right? So each atom has different disintegrating rate. That means activity is different for different atoms. So sum of all these atoms, that is lives of, that is time to disintegrate from, if the atom has 100, that is mass of the nucleus is 100, then the rate of disintegration from 100 to 0, that means complete disintegration of that nucleus from 100 to 0. So the time taken for the total disintegration of one atom, that one we call as life or half-life. So if it reduces to 50, then that one we call as half-life. So completely from 100 to 0, then that one we call as life. So each atom has individual life, right? So sum of all the lives, right? Complete disintegration of all the atoms in the sample to the total number of atoms present in the sample. For example, here we have 100 atoms, then the total lives of, for example, the life of one atom is 1 hour, then the life of second atom is 5 hours, and similarly if we add all the lives of, that means the time period to disintegration from, completely disintegration from original value to 0 value, so that one we call as life, right? So that means the time period to disintegrate the total number of nuclei to 0, that one we call as life, that one is the time, right? So for one atom it may be 1 hour, 5 hours. Similarly if you take for 6 hours, likewise for complete total number of atoms, that means we are adding the all the lives of atoms which are present in the sample to the total number of atoms, right? So here in this sample we have 100 atoms, means divided by 100. So that one we call as mean life. That means sum of lives of all the atoms in the sample to the total number of atoms present in the sample, right? So each atom has maybe same or different life to disintegrate from its original value to 0, right? So that one divided by total number of atoms present in the sample. So that one we call, that is mean life or average life, right? So for this we have mathematical relation total life of all the atoms in the sample, that is equals to, if we have several number of atoms present in one sample, that is equals to integrating from n0 to 0. That means overall disintegration of all the atoms. So initial value is how much? n0, that is the parent atom. That is, if n0 is 100, then that value is 100, right? That is to reduces to which value it is? 0 value. So this one is the lower limit and this one is the upper limit. That means it disintegrating from n0 to 0, right? So that is Integration means sum of all, that is summation. So summation can be written in the integral form, that is n naught to 0, that is t into dn, right? So but we know that is dn by dt, that is equals to lambda n. So this is by the radioactive decay law, that is rate of disintegration per unit time is directly proportional to the number of nuclei, right? So if we remove the proportionality, we get dn by dt is equals to lambda n, right? So we need dn, that is dn is equals to lambda n dt, right? Now we substitute this here because we have dn, then that is equals to n naught to 0 t into, so in place of dn we are writing lambda n dt, right? So if we call this one as equation 1, right? So here I will write from equation 1, right? Next, we also know that n is equals to n naught e to the power of minus lambda t, right? So this one is also derived from the decay law, right? N is equals to n naught e to the power of minus lambda t. So this one is equation 2, right? So this is continued here, the total life of all the atoms present in the sample, that is the numerator value which we are finding that one, that is total life of all the atoms in the sample, right? So that is equals to here it changes, time changes means here the limits also changes from 0 to infinity, right? So here 0 to infinity t lambda. So in place of n we are writing n naught e to the power of minus lambda t into dt, right? So this we get the value which we have written here. The sum of lives of all the atoms in the sample is 0 to infinity t lambda n naught e to the power of lambda t into dt, right? So the total number of atoms present in the sample is nothing but n naught, right? So now if we substitute here the mean life tau, that is equals to, in the numerator we have this value, that is 0 to infinity t lambda n naught e to the power of minus lambda t into dt, right? So whole divided by the total number of atoms present in the sample is n naught, where n naught is the number of nuclei present in the sample, is nothing but total number of atoms or nuclei present in the sample. So that can be written as n naught. So here we have a n naught constant and here we have a n naught constant. So in the numerator if we take common lambda n naught 0 to infinity t e to the power of minus lambda t dt whole divided by n naught, right? So here n naught get cancelled, right? So here the average life tau, that is equals to remaining is lambda 0 to infinity t e to the power of minus lambda t dt, right? So this one by solving integration, so in the mass we will get the value, the standard value, that is 0 to infinity in or indefinite integral, right? So integral x e to the power of minus ax dx, right? So this one by integrating by parts method, then we get one value here, right? So I will write directly here. There is no need to solve by mathematically, right? So if we simplify whole this one, we get the mean life tau is equals to 1 by lambda, right? So after simplifying this from 0 to infinity t to the power of minus lambda t dt, so we are getting the mean life or average life tau, that is equals to 1 by lambda. So lambda is the decay constant. So the relation between the t half, that is half life, is 0.693 divided by lambda. So from this, if we write lambda, so here we have 1 by lambda. So 1 by lambda, that is equals to 0. T half divided by 0.693, right? So if we substitute here, we get the mean life tau is equals to half life t half divided by 0.693, right? So this one is the mathematical expression in terms of decay constant and in terms of half life, right? So this one is the definition and this one is the mathematical formula, right? Tau is equals to 1 by lambda, or this one in terms of decay constant. So this is in terms of half life, because we know half life is equals to 0.693 by lambda, right? So from that 1 by lambda keeping as is, so this 0.693 move to LHS means it goes to the denominator 0.693. So 1 by lambda can be written as t half 0.693, right? So we need to remember these two. If they ask for 1 marks, so what is mean life in terms of decay constant means tau is equals to 1 by lambda, right? Or if we written in terms of half life, that is tau is equals to t half by 0.693, right? So the mean life or average life of a radioactive sample is defined as the ratio of sum of all the lives of atoms in the sample to the total number of atoms present in the sample, right? So that can be written as tau is equals to 1 by lambda, right? So in the next class we will solve few problems based on all the three topics. So one is mean life, half life, and the mass binding energy, right? Binding energy per nucleon and binding energy EB and EBN, right? So in the next class we will solve problems on this topic. So this is very important topic in problems. They ask for 5 marks. In the last year also they asked to find the mean life and half life, right? So we will continue in the next class, right? Thank you.